Algebra 1. We're in 8.6 Part 1. We'll be in 8.6 2 days because they cover two things. And whether we were in school or not in school, I always split this section in half. It's just easier to isolate the two concepts that we'll be doing on the homework page. So we're going to do the half today that's titled Mixed Expressions. A mixed expression is what it sounds like it would be from your 7th grade math days. Like this is a mixed number. It has a whole number part and it has a fraction part. So if you look around your page of notes in your packet, or if you look around the board, what I have up here, I have a mixture of problems where there's half of it that has a fraction and half of it that doesn't. There's always a whole number kind of thing, and then there's a fraction kind of thing that goes with it. They're all like that. That's what a mixed expression is, and the notes say it's a polynomial plus or minus a rational expression. That's just a fancy way of saying there's a thing without a fraction and a thing with a fraction. This is a monomial. This is a monomial. This is a binomial. Those are all types of polynomials. And all of the fractions are rational expressions. So the second line of notes gives you the strategy for today, which is to put the polynomial on top of a 1. And then we're going to just add and subtract the way we have been our whole life with common denominators and those kind of things. So right now, this is invisibly on top of a 1, and we can make that be visible. If we want to make a common denominator now that this is a fraction, we look at the bottoms as we just got done doing a lot, and the common denominator would be an x. This doesn't have an x on the bottom, so we stick one on there. And if we change the bottom, we have to change the top. And now we're ready to make an answer from that. The bottom, the common denominator, does not change. And on top, we think about 2x plus 1 if we can do anything about that with like terms, but we cannot. So that's all we can do. Next one, we go the same way. Invisibly, this is on top of a 1. So we can make that be semi-visible if we wish. But we don't want it to be on top of 1 forever. For us to subtract with fractions involved, we need a common denominator. Since this has an AB, we need to insert on the bottom an AB. And if we change the bottom, we have to change the top. Whatever we're throwing on the bottom, we throw on the top. And then it's answer time. The common denominator has been established. 4AB minus 3, can we improve that? Not really. So 4AB minus 3 is it. As soon as you see the problem, you know what the answer is going to have on the bottom. This answer is going to have the x minus 2 on the bottom. It's just a matter of making this cooperate. This, we're going to come up with a 4x on the bottom. It's just a matter of making that stuff cooperate. When I go to do this last problem, I'm going to need an x plus 2 on the bottom. It's just a matter of making this cooperate. Whatever bottom we have, that's the bottom we're going to use for everything. We just have to make the other piece agree with us. Essentially what we're doing is the algebra version of the bottom times the whole number adds the top to make 7 halves. That's basically what we just did. Okay. If we retread this back to the beginning where we started, the bottom multiplied the whole number and added the top. We kept the same bottom. That's basically what we're doing, just with algebra stuff. So for this problem, the bottom needs the x minus 2. So the top needs an x minus 2. I'm going to need parentheses there because the x is going to go with all of that. And we're going to have a distribute to do because of that. If we distribute this, we're going to get x squared minus 2x. And then the grand total would be an x squared minus a 2x minus a 4. As always, we should think about whether we could factor to try to help us simplify at the end, but that top will not factor. So we're good, we're done. For this problem, we can see the 4x on the bottom. So we need this piece to gain that same 4x on the bottom. The top invisibly has parentheses already, and let's have it gain the 4x. do a distribute so we can get out these pieces. That would be 4x squared plus 12x. And then these should try to add the other pieces. We'd have a 4x squared plus a 14x plus a 3. I should think about factoring that top, but I can't, so I don't, and I just keep on moving. This problem, we know a bottom we need to have, it's x plus 2. So we need this to have an x plus 2. And there are always those invisible parentheses lurking about everywhere. On the bottom, we made this happen, so we need to make that happen on the top. And this top is going to need FOILed. This would be an x squared, a 3x, a 2x, and a 6 from multiplying x squared here, 3x from there, 2x from there, 6 from there. Put that all together with the extra 2 that we had from the way beginning, and we have an x squared plus a 5x plus an 8. These two made the 5x. The 6 and the original 2 made the 8, and we should think about if we can factor, but again, we can't. You usually can't. Maybe once in a long while it will, but it's going to be pretty rare that you can factor. Factoring might let you cancel. It still might not even let you cancel. If you can't cancel, it doesn't even do you any good to factor. But that's our day. The homework build from this is 339. There's a 1 to 12, and then we skip the middle because that's the next lesson, and then we go back in action 29 to 34. So if you have questions, email me. We'll try to get some kind of communication going over questions.